to students. In this video today we will be learning how to find the zeros of polynomial functions. Okay, that is what we will be doing today. Your heading for today then is obviously finding zeros of polynomial functions, lesson 9.5, and be sure and include today's date. Alright, be sure and include today's date. Now, I'm going to be honest with you. I'm going to give you a lot of information today. A lot, okay? You need to understand that. I'm going to teach you a topic that is not easy to understand, nor is it easy to teach. But I do love a challenge, and I hope you do also. So, take really good notes. Pay close attention to what I say. Use the rewind button or the pause button as much as you need to. Take side notes off to the side. Work really hard and you'll be okay. Here we go. First, it is important that I review the difference between rational and irrational numbers. So let's start there. Alright, here we go. Now take some really good notes. Rational numbers. Irrational. If you have had this in the past and you found it difficult, there's really no excuse for that as in terms of how it was taught. Okay, this is very simple. It is so easy. Rational numbers are integers. I'll explain that in a second. Or fractions with integers. Isn't that easy? I mean, that's a piece of cake. It's that simple. So an integer is like -3, -2, 0, 1, 6, 9. It's whole numbers. Positive. Whole numbers, negative, and 0. That's what integers are, okay? So any positive, negative, whole number, or 0 is rational. Fractions with integers, in other words, if we had a fraction like this, pi over 6, that is not rational. Is this an integer right here? Yes, it is. But is this an integer? Not at all. An integer is positive and negative whole numbers and 0. Okay? So, a rational number is fraction that has integers. So, 6 over 7 is rational. Is 6 an integer? Yes, it is. Is 7 an integer? Yes, it is. Now understand this, students. Understand this, guys. If I have 6.7 over 9, 0.23 or something like that, you would look at that and say, oh, that's not rational because I do not have an integer here. Well, listen, guys. You first simplify the fraction. In other words, I can move the decimal up top 2 places as long as I move it 2 places down here. And now I have 670 over 923. So this would be a rational number. Okay? Look, guys, it's just that simple. Rational numbers are negative and positive whole numbers and 0. And any fraction that can be simplified down to integers up top and the bottom, and you have rational numbers. It's nothing more difficult than that, okay? It's that easy. Now, irrational are numbers that don't repeat. And they also don't terminate. And you're probably thinking, what are you talking about? Well, let me show you. Pi does not repeat and it does not terminate. It goes on and it never repeats. 3.14 ... The number e that we learned about earlier this year does not terminate nor does it repeat. It goes on and it never repeats. Now 1/3 goes on, right? But it repeats. Okay, that's why 1/3 is rational. Okay? Irrational numbers don't repeat and they don't terminate. Got it? Other examples. what does the square root of 9 equal? 3, and 3 is a whole number. So the square root of 9 is rational because the square root of 9 equals 3. However, if I change this to an 8, the square root of 8 is irrational. Do you know why? Type into your calculator and you'll see why. It doesn't repeat and it doesn't terminate. Any square root of any number that is not a perfect square, that is an irrational number. Okay, what's a perfect square? Well, you know. 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, etc. Those are perfect squares, okay? So if you have the square root of a perfect square, that's rational, because the square root of 64 is what? 8, and 8's rational. But if you have the square root of a number that's not a perfect square, like 65, that's irrational. I'm going to go over this one more time. We're moving on. Rational numbers are integers, positive, negative, and 0, or fractions that, after you've simplified the fraction, have an integer up top and an integer in the bottom. It's that simple. Irrational numbers are any numbers that don't repeat and they don't terminate. The most common irrational numbers in Algebra 2 would be pi, e, and square roots of any numbers that are not perfect squares. Now, I've rambled a lot. Take really good notes. Pause the video, back it up. But I told you, I'm going to give you a lot of information today. Rational, irrational, you need to know the difference. We're going to use that later in our math today. Okay, moving on. Now let's talk about what it means when I say to you, find the zeros of a polynomial function. Okay, let's talk about this. Write this down. Write this down. Finding the zeros of a polynomial function just simply means to find the x values that make the y values 0. Please copy that down. Please copy that down. Now, as you're copying that down, don't worry. I'm going to explain what this means right now. So copy that down, okay? Then we'll talk about it. When I ask you to find the zeros of a polynomial function, I am saying to you, find the x values that make the y value 0. Okay, I'm going to explain that right now. Got it? Copy this down in your notes, please. If you're not done, copy this down, pause the video. Here's what I mean by the x values that make the y value 0. Copy this down, please. Okay, now, would you please watch what happens when I substitute, let's see here, a positive 6 in, okay? Watch what happens when I put 6 in for x. Six times 6 is 36. Negative 5 times 6 is negative 30. Bring down your negative 6. Negative 30, negative 6 is negative 36. Bring down your 36. What do you get? 0. Do you see what I'm saying now? My x value was 6. That made my y value become what? 0. I want you to find the x values that make the y value become 0. So when you put 6 in for x, what did you get out for y? 0. Thus, you know what you say. 6 is a 0 for this function. Why is 6 a 0? Because when you put 6 in, you get out 0. Listen, try another number, okay? Try negative 1. Try negative 1 and watch what happens. Put a negative 1 in for x. Negative 1 times negative 1 is positive 1. Positive negative 5 times negative 1 is positive 5. Bring down your negative 6. Positive 1, positive 5 is positive 6. Positive 6, negative 6 is 0. So, now Mr. Aaron, how did you know those two numbers? Look, I could do these in my head. Don't worry about that, okay? Did I have this problem worked out ahead of time? No, I did not. I just wrote it down, and I can figure it out. I've done tons of these, okay? Now look, when I put negative 1 in for x, what did I get out? 0. So the x value that made my y value 0 is negative 1. So you would say negative 1 is a 0 for this polynomial function. Now, by the way, you'll never have more zeros than the degree. So I didn't say you would have to have that many. I said you'll never have more than that. So what degree is this polynomial function? Second degree. How many zeros do I have here? 2, so I'm finished. Those are the only zeros that exist. Got it? So do you see what I mean now when I say to you, finding the zeros of a polynomial function just simply means to find the x values that give you an output of 0, or in other words, x values that make the y value 0. So you're trying to find x values that make the y value 0, okay? Now watch that again if you need to. It's important you understand that. So that's what I mean when I say to you, find the zeros of a function. Now, there's something else I want you to write down, okay? Write this down. The zeros of a polynomial function are also the x-intercepts. Got it? The zeros of a polynomial function are also the x-intercepts. Write that down, please. The zeros of the polynomial function are also x-intercepts. Now, let me go back a page here real quick, okay? Now, what did I tell you my two zeros were for this function? Do you remember? 6 and negative 1. So you know what that means? If you were to graph this function, the graph would cross the x-axis at 6, and it would cross the x-axis at negative 1. Isn't that cool? So when you're finding zeros, you're really finding the x-intercepts. Write that down. You need to understand that. Let's review. When I tell you to find the zeros of a polynomial function, I'm asking you to find the x values that make the y value 0. Got it? I will teach you how to do that later. Number 2, when you find the zeros, they are the same thing as the x-intercepts. That's going to help us later when we go back and start graphing some of these polynomial functions, okay? So write that down. The zeros of a polynomial function are also the x-intercepts. You need to know that. So now you know two things about the zeros of a polynomial function. You know that they are the x values that make the y value 0, and you know they are the x-intercepts of the graph. Let me show you what I mean, which I just did that, okay? Now, let's start getting into the meat of this lesson, what we're really going to do today. I've laid a little bit of a foundation for you, and now let's jump into this. I want you to find the zeros of this polynomial function. Got it? I want you to find the zeros of that polynomial function. So copy this in your notes. Copy this in your notes, please. Find the zeros of this function. Now you're probably saying, you haven't taught us anything, Mr. Arrow. We have no idea how to do this. Well, hold on. I've taught you a little bit of stuff. First of all, I just taught you, are you ready? Are you listening to me? I just taught you that the zeros are the what? X-intercepts. I just taught you that, right? So, if I ask you to find the zeros of this function, that means I want you to find the what? We know how to find x-intercepts. Come on, guys, we're Algebra 2. Anytime I ask you to find the x-intercept of an equation, you put 0 in for what? Y. You guys know that. Anytime I ask you to find the x-intercept of an equation, you put 0 in for what? X. So what am I asking you to find? The zeros. What are the zeros? The zeros are what? X-intercepts. Got it. So when I ask you to find the zeros, I'm really asking you to find the what? X-intercepts. How do you do that? You put 0 in for y. So you know f of x is the same thing as y. So I really have y squared equals x squared plus 3x minus 10. So what am I going to put in for y? I'm trying to find the zeros, which is the same thing as find the x-intercept. So I'm going to put 0 in for y. guys, we knew how to solve this. We just did a bunch of these on your quiz about 2 weeks ago. Factor this thing. Remember, we knew how to solve this. Factor it. This is a trinomial with a lead coefficient of 1. So what two numbers would multiply together give you negative 10? When add together give you positive 3. Would it not be these two numbers here? Multiply those two numbers together, you get negative 10. Add those two numbers, you get a positive 3. So now you have this, x plus 5, x negative 2. Remember this? We did this a couple weeks ago, guys. So let's review again. I'm asking you to find the zeros, which is the same thing as finding the what? X-intercepts. And how do you find x-intercepts? Put 0 in for y. So put a 0 in for y like I did here, and then solve. Now remember what to do. You take each group and set each group equal to 0. And then solve each group. Now students, we take each group, now we solve each group, so x equals negative 5 and x equals positive 2. Alright, so you did it, you found the zeros. So there, the zeros for this function are negative 5 and positive 2. Now if you don't believe me, plug it in and watch what happens. Put a negative 5 in. Negative 5 squared is 25. Put a negative 5 here. 3 times negative 5 is negative 15. Bring down your negative 10. Negative 15, negative 10 is negative 25. 25 minus 25 is 0. So when you put negative 5 in, what'd you get out? A 0. Now we're going to put 2 in for x. 2 squared is 4. Put a 2 right here. 3 times 2 is 6. Positive 4, positive 6, positive 10 minus 10. Look at that. When you put in the number 2, you got out a 0. Okay? So, you found the zeros, or the x-intercepts, for this function. Okay? Pretty good. Not too bad, right? So you're probably thinking, after that example, these problems look really easy, don't they? Well, don't get too excited. That's about as easy as they come. What if that function had not been factorable? Okay, what happens then? Now we'll get to those videos a little later. We'll get to those problems a little later, okay? Alright, here we go. Let's try another function, okay? Find the zeros for this function here. Okay, so copy that in your notes, please. And here we go. Now I'm asking you to find the zeros, which is the same thing as finding the what? X-intercepts, which means you put 0 in for what? Y. Here's your y right here, so put a 0 in for y. 0 equals x cubed plus 4x squared negative 2x negative 8. Alright? Now, we'll just leave it here, I guess. Okay, anyways, so we're going to find the zeros. Now, students, listen, if you're kind of struggling with this, remember, I understand these are not super easy, but we did do these a couple weeks ago, okay? Now look, we did these in the past. We're solving a third-degree polynomial function set equal to 0, so we factor this side. Remember, we have a 4-term quadnomial, so we pull out what's common in the first two terms. X squared, leaving you with x plus 4. Now we pull out what's common in the second two terms. Well, 2 goes into 2 and 2 goes into 8. Whenever this term is negative, you plot a negative sign. And we're left with x plus 4. Now check it and make sure I'm right. Negative 2 times x, negative 2x. Negative 2 times 4, negative 8. So do my parentheses match right here? Yes, they do. So I write my matching parentheses once, and I'm left over with x squared minus 2. Got it? All of that equals 0, of course. Do you see what I did? I factored this. Now, take x plus 4, set it equal to 0. Take x squared negative 2, set it equal to 0. Let's solve. Bring this 4 over, make it negative. And you get negative 4. There's 1 0. Now, bring the 2 over and make it a positive 2. And now take the square root of both sides. The square root of x squared is x. Now watch. You need to get used to not taking the square root with your calculator, but just leaving it a square root like this. Now don't forget to put what right here? Plus, minus, positive, negative. So there's your other two zeros. I brought the 2 over, made it positive, and I took the square root of both sides. So you did it, guys. You just found the zeros for this third degree polynomial function. Negative 4 and positive negative square root of 2. Look at that. And that's 3 zeros. 1, 2, 3. There's 2 zeros here and 1 here. What's the degree? Third degree, so we know there's no more zeros. Okay, so there we go. We did it. Alright. Okay, so we've done 2 problems in which you could factor the polynomial, right? Now let's look at some functions in which you cannot factor the polynomial. And this is where it gets really crazy, okay? So dig in and get ready to take some really good notes. First, always try to factor the function first. Always. That's what we did right here, right? We factored. Correct. That's what we did up here. We factored. Right? Always try to factor first. Listen, guys. If it's factorable, then you will save yourself a ton of time. However, after you've tried to factor it and you can't, then you need to do some other things, okay? That's common sense. Now, this problem here was factorable, so no problem. This problem here was factorable, no problem. But what if it's not factorable? You will want to make a list of the possible rational zeros that might exist, okay? Now, let's take a look. Let's take the last problem that we just did. Let me show you how to make that list, okay? Because, listen, guys, is everyone listening? Listen. There's no way you can find the zeros unless you make a list of numbers that you can test to see if they are zeros. So there is a certain specific way to find or to make a list of possible rational zeros. And I want to show you that right now. So are you ready? Please take some stellar notes. Here we go. Take this problem we did up above and write it down. I'm going to show you how to make a list of possible rational zeros. Now, before I do that, understand something. If I gave this problem on a quiz or a test, was it factorable? Yes, it was. So you would normally not make a list. You would just factor it and solve it. But just for example's sake, I'm going to show you how to make a list of possible rational zeros. Here we go. Are you ready? Okay. Make sure it's written in standard form. That's the first thing you do. Got it? Take some side notes, guys. I'm telling you. I'm going to give you tons of information today. You've got to listen, okay? Now look. Make sure it's written in standard form. Then you take your lead coefficient, which is 1, and you put it right here. Got it? You take your constant term and you put it right here. Don't worry about the signs. The signs do not matter. Do not worry about the signs. The signs do not matter. I will show you why later. So is everybody with me? Take your lead coefficient, write it here. Everyone can do that. Take your constant term, write it here. Everyone can do that. Now, list out all the factors of 1. Well, the only factors of 1 that I know are 1 times 1, okay? And you do not want to have double numbers, so 1. Now, what's the factors of 8? We know the factors of 8. Come on, guys. 1 times 8 and 2 times what? 4. Those are the factors of 8. Got it? That's easy, isn't it? Sure it is. If I said list out the factors of, I don't know, some crazy number like 24, no big deal. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and you know you're done. Because if you get up to 6, then you start repeating yourself. 6 times 4, which we already have. So there's the factors of 24. Just start at 1 and work your way up, okay? So here's the factors of 1, 1. Here's the factors of 8, 1, 8, 2, and 4. Now, you take each one of these numbers and you put them on top of these numbers over here. do? You take your lead coefficient, write it right here. Take your constant term, write it right here. List out the factors of your lead coefficient, list out the factors of your constant term. Take each one of these numbers and put them on top of this number over here. Okay? Then after you do that, put plus minus in front of each number. Now, you just made a list of possible rational zeros right here. Now, see this function right here? This function right here? Listen to me carefully. Any rational zero that exists will be in this list right here. Now, obviously, there's 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. Obviously, all 8 of these numbers are not zeros for this function. I know that, but if there is a rational zero for this function, and we know there is because we already solved it, if there's a rational zero for this function, it'll be somewhere in this list, guaranteed. That's a mathematical fact, okay? So, let's go back a page or two. What were my zeros for this function right here, do you remember? -4 and plus minus square root of 2. So here's the zeros, -4 plus minus square root of 2. Now, which one of these is rational? Think about what I taught you at the very beginning of the class period. Is the square root of 2 rational or irrational? That's irrational, so it's not supposed to be in this list. This list that you make is only good for rational zeros. Got it? So, is -4 in this list? Yep, booyah right there. There it is. -4 right there. I'm telling you guys, this list is awesome. If you can't factor this thing, you've got to make a list, and then you've got to, it's boring, it takes a while, these are long problems. Then you have to test each number until you see if it's a zero, okay? So this problems can take a while sometimes. Now, let's go over this for the third time. If it's factorable, then you factor it. If it's not factorable, then you make a list of possible rational zeros, and we have to test them. If a rational zero exists, it will be in this list. Now notice, we also have 2 irrational zeros, and that's okay, no problem. But your irrational zeros will never be in this list. Never. Okay? Now, there was something I was going to say about this, it's slipping my mind. Okay, I remember what it was. I was going to say that one of your lead coefficient is 1. Making this list is really easy, okay? So I want to practice another problem where we make a list of possible rational zeros, okay? In which the lead coefficient is not 1. Those are a lot more difficult, okay? So here we go. Copy this in your notes. Let's practice another example where we simply list out the possible rational zeros. There it is. Please copy that down if you would. I want you to simply make a list of possible rational zeros. Are you ready? You can work ahead or you can watch me. First of all, make sure it's written in standard form, and it is. Next, write down your lead coefficient. Write down your constant term. Don't worry about the signs. Now, list out the factors of each number. So start with number 1. 1 times 6. 2 times 3. And that's it. So 6 has 4 factors. Now 12. 1 times 12. 2 times 6. 3 times 4. There we go. 12 has 6 factors. Now, here's where it gets really tough, okay? We're going to take each one of these numbers and put them on top of each number over here. So please watch how I do this. See, 1, put it over 1. 1 over 1 is 1. Now put 1 over 6. 1 over 6 is 1/6. Now put 1 over 2. That's 1/2. Now put 1 over 3. 1/3. You see how I did that? I took the number 1 and I put it on top of each one of these numbers. This can take a while, guys, okay? Now, cross off the 1. You're done with it. Now let's use the 12. 12 over 1 is 12. 12 over 6 is 2. 12 over 2 is 6. And 12 over 3 is 4. Okay? 12 divided by 1 is 12. 12 divided by 6 is 2. 12 divided by 2 is 6. 12 divided by 3 is 4. Now let's take our 2. 2 over what? 1. 2 over 1 is what? 2. What do we already have right here? A 2. So don't write it twice. 2 over 6. Well, 2 over 6 reduces to what? 1/3. Don't we have 1/3 already? Sure we do, so don't worry about it. 2 over what? 2. I already did 2 over 1. I already did 2 over 6. Now, 2 over 2 is 1. I already have 1. Don't worry about it. 2 over 3 is 2/3. Do I have 2/3 up here yet? No. So 2/3. So now we're going to cross off the number 2 and go on to 6. 6 over 1 is 6, but we already have a 6. 6 over 6 is 1. We already have a 1. 6 over 2 is 3. We'll put a 3. 6 over 3 is 2. We already have a 2. Now we'll go to 3. 3 over 1 is 3. We already have a 3. 3 over 6 is 1/2, right? If you reduce it, we already have 1/2. 3 over 2 is 3/2. Do we have 3/2 yet? Not at all. And 3 over 3 is 1. We have a 1 already. So we're done with 3. 4 over 1 is 4. We have a 4 already. 4 over 6 is 2/3. We have 2/3 already. 4 over 2 is 2. We have a 2 already. And 4 over 3 is 4/3. And we do not have a 4/3 yet. And then lastly, put plus minus in front of all these numbers. Dudes, students, do you not see how long these problems could be? If this function right here is not factorable, you have to start testing each of these numbers. What I do? I have to test each of these numbers until I find a 0. And so, look how many numbers I have to test. Each one of these is 2 numbers. Plus minus, plus minus. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 2. I've got 24 numbers. I've got to try to test until I find a 0. Okay? Now, will I give you one like this on a test or a quiz? Of course not. That's ridiculous. But you still need to know how to make a list of possible rational zeros. Because if this problem's not factorable, you've got to make a list of possible rational zeros. Are you listening? If there is a rational zero in this list, if there's a rational zero for this function, it'll be in this list somewhere. Period. It has to, if it's rational. Okay, so if this polynomial function has a rational zero, it will be in this list. And that's why that list is so important. Got it? Okay. You write the lead coefficient. You write the constant term. Write out the factors. Write out the factors. And then don't get confused. You do not put these numbers on top of these numbers. You put these numbers on top of these numbers. Okay? Alright. Then don't forget your plus and minuses in front of each number. The only thing left for us to do now is to learn how to take the possible rational zero list and test them and see which of these numbers are truly zeros. So let's give that a shot, okay? Let's do that. So here we go. Let's give this a shot. It's going to be tough. Let's see if we can do it. Let's find the zeros for this function. Copy that in your notes, please. Please copy that in your notes. Let's find the zeros for that function. Now I want you to take some really good notes. I know I've said that 2 or 3 times, but take some really good notes, alright? Here we go. Find the zeros for this function. I'm going to slide this over so it's in the middle of the page here. Now let's find the zeros for this. What did I tell you way back here? What did I tell you? Here it is. Always try to do what first? Factor. Always. Got it. So let's try to factor this thing first. It's a quadnomial. How do you factor a quadnomial? Remember, first of all, if you're trying to find the zeros, you put 0 in for y. So we put a 0 right here. Now let's try to factor this. How do you factor a quadnomial? Pull out what's common in the first 2 terms, x squared. Then pull out what's common in the second 2 terms, which would be a 3. 3 goes to both those numbers. And because this is negative, pull out a parentheses here match this parentheses here? Not at all. So it's not factorable, guys. You can't factor it. Forget it. Okay? So if we can't factor it, what are we going to do? Well, we're going to list out the possible rational zeros. So here we go. Your lead coefficient, make sure it's in standard form. It is. Your lead coefficient is 1, so put a 1 here. Your constant term is 45, so put a 45 here. Now, what are the factors of 1? 1 times 1. We don't want any double numbers, so just 1. What are the factors of 45? Well, 1, 45, 3, 15, 5 times 9, 6, 7, 8, 9. No, now we're starting to repeat. Now it's 9 times 5, so that's it. There's the factors of 45. So take each one of these numbers and put them over 1. So 1 over 1 is 1. 45 over 1 is 45. 3 over 1 is 3. 15 over 1 is 15. 5 over 1 is 5. And 9 over 1 is 9. So there's your list of possible rational zeros. Now we got to test these and find some zeros, okay? Now, I hope I haven't lost you yet, guys. Listen to me. Try to factor it first. If this function right here is not factorable, then you make a list of possible rational zeros, alright? Now for me, I always start with the smaller numbers and work my way up to the bigger numbers. So the first number I'm going to test is 1. Now here's what you're thinking. Are you ready? Here's what you're thinking. You're thinking, oh, Mr. Earhart, I got to put a 1 in for x and see if I get out a 0. You know how much time this is going to take? Dude, students, not at all. Remember how I taught you to use synthetic division? We learned that recently in a video. Probably the last video we did, right? I showed you how you can use synthetic division to get out values. I taught you that. So let's use synthetic division. It's so fast. Watch. We're going to test the number 1, okay? So I'm not missing any terms. I have a 3, a 2, a 1, and a 45. I'm not missing any terms. So my coefficient is 1. My coefficient is negative 1. My coefficient is negative 21. And my coefficient is 45. Got it? Let's test the number 1. Let's put a 1 here. Let's test it. I should get out a 0 right here if it's a 0. Are you ready? Here we go. Bring down your first number. 1 times 1. Combine. You get a 0. 1 times 0. 0. Bring down. Combine. No way, guys. No way. Am I going to get a 0 here when I combine these? No. So 1 doesn't work. So forget the number 1, okay? It's not going to work. Forget positive 1. Let's try negative 1. Let's try negative 1. Here we go. Bring down your 1. Negative 1 times 1. Negative 1. Combine. Negative 2. Multiply. Negative 1 times negative 2. Positive 2. Combine. Negative 19. Negative 1 times negative 19. Positive 19. Am I going to get a 0 here? No, I'm going to get 64. Okay? So 1, negative 1 does not work. Alright? So forget this. What's the next smallest number you see? 3. Let's try positive 3. 3 times 1. 3. Combine. 2. 3 times 2. 6. Combine. Negative 15. 3 times negative 15. Booyah, look at that. Negative 45. I get out a 0. Okay? Now that's going to be a big help to me. So positive 3 is one of my zeros. I put in 3 and I got out what? 0. Do you understand? Okay? I'm testing these numbers. So now I'm making my list of zeros up here. So far one of my zeros is what? 3. Now here's what's so cool. I can read y'all's minds like a book. You're thinking, Mr. Earhart, I am quitting Algebra 2. You're thinking you have to go through and continue to check all these numbers. Not at all, guys. Remember what I taught you about synthetic division? Yes, listen to me. Synthetic division does give you out a value over here, but it also does something else for you too. Okay? It also, remember, gives you this. Remember, what is your degree right here? 3, right? So we go 1 less than that, and we have 1 x squared, 2x, and that's your constant term. factorable? No. So I listed out my possible rational zeros. Got it? After I did that, I then started testing my numbers until I found a zero. Once I found a zero, I wrote down my reduced polynomial function. And now I don't need this. And since this is factorable, now if it wasn't factorable, I would still need this list of numbers. And we'll get to that later, okay? But this is factorable, so I don't need this list of numbers anymore. I don't even need this anymore, to be honest with you. I've got this now. I can factor this. Okay? You can, yeah, definitely. Trinomial lead coefficient of 1. What two numbers would multiply together give you negative 15 when add together give you positive 2? Well, these two numbers. Multiply those, you get negative 15. Combine those, you get a positive 2. So x positive 5, x negative 3. Of course, this whole thing should be set equal to 0. Take each group and set each group equal to 0. And solve. Bring your 5 over and make it negative. Bring your 3 over and make it positive. There we go. You found the zeros, guys. 3, negative 5, and 3. Oh, look at that. So it's possible to have a repeat zero, isn't it? Look at your original problem. It was a what degree? Third degree. So at the most, how many zeros could you have? 3. And we really only have 2 because you don't need a repeat zero. Now, on a test, if you told me these were the zeros, I would not take any points off. I don't care. But really, the zeros are 3 and negative 5. 3 and negative 5. So if you were to graph this, you would have an x-intercept at 3, and you would have an x-intercept at negative 5. Okay? Alright, we did it. Let's try some more of these, okay? We need to practice. Now the last problem we did was a third degree polynomial function. Let's try a fourth degree. Then we're going to try a fifth degree, and then we'll be finished. You can work ahead if you want to. I love it when y'all work ahead, okay? I have no problem with that. So here we go. Step 1, what do you always try to do first? Always. Factor. Correct. Sure. Always. Always factor first. The problem is, we've never learned how to factor a 5-term expression, so we can't factor. There's no way we can factor that, okay? It's impossible. So we cannot factor it. So if we can't factor it, what's the next thing we do? We make a list of possible rational zeros. So is it written in standard form? Yes, it is. Here's my lead coefficient. Here's my constant term. Don't worry about the signs. Now, what is the factors of 5? 1 times 5. What's the factors of 20? 1 times 20. 2 times 10. 4 times 5. And that's it. Then it starts to repeat 5 times 4. That's it. Now take this 1 and put it over 1 and put it over 5. 1 over 1 is 1. 1 over 5 is 1/5. Okay, we're done with the 1. Put 20 over 1, that's 20. 20 over 5 is 4. It reduces to 4. So we're done with 20. Put 2 over 1, that's 2. Put 2 over 5, that's 2/5. We're done with 2. Put 10 over 1, that's 10. Put 10 over 5, that's 2. We already have a 2 right here, so we don't worry about that. Put 4 over 1, that's 4. We have a 4 already. Put 4 over 5, that's 4/5. Put 5 over 1, that's 5. Put 5 over 5, that's 1. 5 over 5 is 1. We have a 1 already. So there we go. There's our list of possible rational zeros. So students, my smallest number, when I say smallest number, I don't count fractions. Listen, always say fractions until the end, okay? Always, because they're a pain to do. Can you imagine doing synthetic division with the number 1/5 right here? I mean, it's pretty, it takes a while, so save your fractions for last and hopefully you won't have to use them, okay? So the smallest whole number up here is 1, okay? Now, I'm not missing any terms. 4, 3, 2, 1, constant term. So I've got a 5, 11, negative 48, negative 110, negative 20. Now, remember the trick I taught you? Take the degree and add 1 to it, you get 5. You should have 5 numbers here, and I do. Now we're going to test the number positive 1, so here we go. Bring down your 5. 1 times 5, combine. 1 times 16, combine. You would get negative, what, 32, I believe. Yep. 1 times negative 32, negative 32. Combine negative 142. Multiply 1 times negative 142, not even close. We're not going to get a 0 here. So that did not work. So if 1 didn't work, let's test negative 1. Bring down your 5. Negative 1 times 5, negative 5. Combine 6. Negative 1 times 6, negative 6. Combine negative 54. Negative 1 times negative 54, positive 54. Combine, and what would you get here, guys? 46, negative 56. I believe I did that in my head. But you know what? It really doesn't matter. You're going to multiply. There's no way you're going to get a 0. So it doesn't matter, okay? Alright. So negative 1 doesn't work, and neither does positive 1. So we can cross those off the list. Gone. What's the next smallest number I have? 2. Let's try a positive 2. 2 times 5, 10. Combine, 21. 2 times 21, 42. Combine, negative 6. 2 times negative 6, negative 12. Combine, negative 1, 22. Obviously, we're not going to get 0. 2 times this is negative 244, so we're not going to get a 0. So 2 does not work. Let's try negative 2. Negative 2 times 5, negative 10. Combine 1. Negative 2 times 1, negative 2. Combine negative 50. Negative 2 times negative 50 is positive 100. Combine negative 10. Negative 2 times negative 10, positive 20. 0. Booyah. Okay? So negative 2, I put in a negative 2. I got out a 0, so negative 2 is one of my zeros. Alright, that's good. Now, I have shrunk. I have reduced my function. It was a 4th degree. Now it's a 3rd degree. So I have 5x cubed, positive 1x squared, negative 50x, negative 10. I think this is factorable, guys. I think we can factor this. That'll save us a lot of time, okay? Let's see if it's factorable. I think it is. Alright, here we go. Let's see if this is factorable. It's a quadnomial. How do you try to factor a quadnomial? Pull out what's common in the first 2. And you're left over with that. Pull out what's common in the second 2. 10. 10 goes into both of those numbers. And because this is negative, put a negative. And you're left with 5x plus 1. Look at that. It worked. Okay? So write your matching parentheses once. And then you're left over with x squared minus 10 in your other parentheses. Alright? Now, take each group, set each group equal to 0. Bring the 1 over and make it a negative 1. Divide both sides by 5 and you get negative 1/5. So there's another 0 for your list. Negative 1/5. Now let's solve this equation. Bring your 10 over and make it positive. Take the square root of both sides. The square root of x squared is x. The square root of 10 is positive negative square root of 10. So positive negative square root of 10 would be another zero. Actually, two zeros. Look at that. We did it, guys. Put a comma here. So negative 2 is 1 0. Negative 1/5 is 1 0. And then plus minus square root of 10 is two more zeros. We have four zeros here. And by the way, guys, hey, listen to me. Listen, I erased your possible rational zero list. But look at, you should still have it in your notes. Look at your list of possible zeros. Is negative 2 in that list? Yes. Is negative 1/5 in that list? Yes. Because these two zeros are what? Rational. I'm telling you, if a rational zero, if this function right here has a rational zero or more than one, it will be in that list of numbers. Now, do you see square root of 10 in your list anywhere? No, of course not. And you shouldn't, because square root of 10 is what? Irrational. Okay, guys, you better be seeing the difference here. Alright, one more problem. We're finally done. Okay, one more. Here we go. You can work out if you want to, but it's a pretty tough problem. Actually, it's a very tough problem, so please pay attention. Okay, fifth degree. Here we go. Fifth degree. Alright, first of all, try to factor it, but obviously we can't factor it because we've never learned how to factor a six-term polynomial. So we're not going to try to factor it. So if we're not going to try to factor it, the next thing we do is we list out our possible rational zeros. Okay? So here we go. Is it written in standard form? Yes, it is. My lead coefficient is 1, and my constant term is 12. What's the factors of 1? 1. What's the factors of 12? 1 times 12, 2 times 6, 3 times 4. Okay? Those are the factors of 12. Well, we put 1 over 1, 12 over 1, 2 over 1, 6 over 1, 3 over 1, 4 over 1. We just get these numbers right here. So, plus minus 1, positive negative 12, positive negative 2, positive negative 6, positive negative 3, positive negative 4. There we go. There's my list of possible rational zeros. So students, are you listening to me? If this function has rational zeros, they will be in this list, period. Okay? So now we got to start testing these until we find one. Alright, so here we go. I'm not missing any terms. I've got 5, 4, 3, 2, 1, and a constant term. So I'm good. So my coefficients are 1, negative 1, then negative 7, and then positive 7, and then 12 and negative 12. Now, even though we're not missing any terms, it's always good to run a little test and make sure you've not messed up. What is my degree? 5. Add 1 to that and you get 6. I should have 6 numbers here. And I do. Okay, let's start with our smallest number and test it first. 1. So bring down your 1. 1 times 1, 1. Combine, 0. 1 times 0, 0. Combine, negative 7. 1 times negative 7, negative 7. Combine, 0. 1 times 0, 0. Combine, 12. Hey, look at this, guys. We got lucky on the first try. 1 times 12, 12 gives us a 0. Look at that. We're doing pretty good, okay? So, let's see what we have here. We have this is a fifth degree, so now I have it. Well, first of all, 1, I put in 1, and I got out 0. So one of my zeros is 1. Now, I'm left over with, this is a fifth degree, so go 1 less than that. X to the 4th, x to the 3rd, x squared, x, and constant term. So I have x to the 4th, no need to put this term, minus 7x squared, no need to put this term, positive 12. There we go, look at that. Now, I actually made a mistake on this problem. I mean, I didn't make a mistake, but I wanted a more difficult problem than this. I didn't know all these zeros were going to fall in here. So, is this factorable? Yes, it is. But let's pretend that it's not. Okay, now first of all, if you were taking this, if you were solving this problem on a test or a quiz, you would definitely want to take this function right here and factor it, okay? Like this. Mr. Earhart, how's that factorable? Well, let me ask you a question. Is this exponent here twice as big as this exponent? Yes, it is, okay? Is it a trinomial? binomial? Yes. Does it have a leading coefficient of 1? Yes, so we can factor it. What two numbers multiply together give us 12, when add together give us negative 7? How about these two numbers here? So when you go to factor it, please do not put x minus 4, x minus 3. You put x squared minus 4, x squared minus 3. Okay, because of your middle term is x squared. So it's factorable. Then you would take each group and set each group equal to 0 and solve. Okay, but let's pretend it's not factorable. Okay, so if it's not factorable, here's what we have to do. We have to do synthetic division all over again. But listen, here's where it gets so cool. You don't use this function. Forget about this function. You use your new function, which is much easier to use. Now, now listen guys, listen. If you test a number and it doesn't work here, then it will not work here either. However, if you test a number and it does work, like 1, it might work again. So sometimes you have to use the same number again, okay? So, let me say that again. Let's pretend we tested 6, and let's pretend it didn't work. Well, if positive 6 did not work in this function, it will not work in this function either. However, if positive 6 did work in this function, it might or might not work in this function, so we have to try it again. So, 1 worked for this function to get me out of 0. So 1 might work for this function. I've got to try it and see. Okay? So we're going to do synthetic division again. So if this was not factorable, now listen to me. If this was not factorable, I know it is, but if it wasn't, then we take this function, not this function. Get rid of this function, it's gone. We take this function, and now we use synthetic division on this. Okay, so here we go. I have a 4. There's no 3 terms, so put a 0. Then negative 7. There's no x terms, so put a 0. And then 12. Okay, I should have 5 numbers up here, and I do, because 4 plus 1 is 5. Now we're going to test 1 again. Okay, bring down your 1. 1 times 1. Combine. Multiply. Combine. Multiply. Combine. Multiply. 1 times negative 6. Combine. Did I get out of 0 right here? No, I did not. Now, that does not mean that you cross off 0 off your list. That does not mean that you cross off 1 off your list. 1 is one of the zeros. It just didn't work for this function. So now let's try negative 1, okay? Bring down your 1. Multiply. Negative 1. Combine. Negative 1. Negative 1 times negative 1 is 1. Combine. Negative 6. Negative 1 times negative 6 is 6. Combine. We get a 6. Negative 1 times 6 is negative 6. Combined, we do not get 0, so negative 1 did not work. Let's try our next smallest number, which is positive 2. Let's try a positive 2, and you're going to see this is going to work. 2 times 1, 2. Combine, 2. 2 times 2, 4. Combine, negative 3. 2 times negative 3, negative 6. Combine, negative 6. 2 times negative 6, negative 12. 0. So I put in a 2. I got out a 0. So 2 is one of my zeros. I did have a 4th degree, so now I have a 3rd degree. I keep shrinking this thing down, okay? So now I have 1x cubed, positive 2x squared, negative 3x, negative 6, and guess what? This is factorable, so I'm done with this testing 0 stuff, okay? This is factorable. So factor it and get this over with. It's a quadnomial. How do you factor a quadnomial? Pull out what's common in the first 2, that's x squared, and you're left over with x plus 2. Pull out a 3. 3 goes into 3 and 6, but because this is negative, pull out a negative, and you're left with x plus 2. Do your parentheses match? Yes, they do. And then you're left over with x squared minus 3 in your other parentheses. Now take each parentheses, set each parentheses equal to 0, and solve. Bring your 2 over and make it negative. X equals negative 2. Bring your 3 over and make it a positive 3. And now take the square root of both sides. The square root of x squared is x, and the square root of 3 is positive negative. Square some commas in here. And by the way, if you want to shrink this list, you could write it like this: 1, comma, positive negative 2, comma, positive negative square root of 2, because you have a positive 2 and a negative 2. No, I don't care how you write it. This is fine, and so is this. So our original problem was a fifth degree function, and we have 5 zeros. We did it. Okay, 5 zeros. 1, 2, 3, 4, 5. How many of these are rational? 3. 1, 2, 3. All 3 of these numbers right here, if you'll look at your possible rational zero list, they're all in there. This is irrational, so it's not in your list, but it's still a zero, of course. Okay? Now, this has been a challenging lesson, I know that, okay? But guys, this is stuff you have to learn, and there's no easy way to teach it or to learn it. You've just got to practice, okay? So you will be given homework, of course, later on. Not with today's lesson to practice, okay? But that's how you find the zeros of polynomial functions. I hope this has helped. If you have any questions at all, don't hesitate to call or email.